Right. So this is one more session here for FatScript, and I'm Antonio. I'm the author of the language FatScript, and tonight I wanted to create a little game, like do it live and see how it goes. So um, my main idea is here we will create like some sort of shooter where basically we have this little spaceship on the left of the screen, which you can control, move it up and move it down. And while you're going through the game, you basically can shoot, and you have those enemies which come from the right hand side of the screen. So yeah, that's basically the idea. And I started also creating a few little like a little initial script just to organize the idea of how this could work. So I did it under um, space. Um, what was it again? Uh, SpaceShip game. Yeah, that's it. And then here I just created some initial setup for it to work. So basically, I import the standard libraries for FatScript. I define frames per second to be 15, could be higher, probably 20 will also work fine. I define a type, which is for position, like XY kind of thing. Then I define what a spaceship is. It has a position, it has a sprite, which is basically a text, it's a character we're gonna use for representing our spaceship. It gets a color, and there is a function to draw like this character on the screen. It just sets the color and it prints that sprite at the position. It also can be erased. I have a move up function, a move down function. The the interesting thing here is I'm using a feature from FatScript that's not, it's like a little bit different from other languages, which is using like this dot um, on an object to access the items. Like this is called the scoped block in FatScript, and what it does is it switches the scope to execute inside this object. So what happens afterwards here is that everything that happens here is happening as if you were writing code running straight from the scope of self, which in this case will be the instance. Um, and then I create a player which I position at a certain position, not very important here at the moment, like 12, considering that's the y, considering the height of the screen of 24, which would be the default one. We actually will have to deal with size of screen very soon to make this game work properly. But for now, I'm not going to consider this too much, just so we can quickly get up and running with something here. And then we have like this main loop, which I just put it into infinity, so it will just loop forever, and it will execute whatever code is in here. So the first thing I'm gonna try to do is, if I press up, I want it to move up. If I press down, I want my spaceship to move down. And if I press space, I want it to shoot. Okay, so let's start with the easiest part here, which would be if I have it up, I want basically, what do I want to happen? I want the player to be erased, then move up, and then draw. Okay. For the initial thing here, so player spaceship, I think we also need to draw this player. So player draw as a first thing. So it needs to be drawn, and then we can start to do this like erase, move up, and then draw. If I want to move it down, it's just the erase, move down, and draw. And then there's this thing here which curses refresh and time wait frames per second. So it's just ensuring that it will refresh whatever actions we take here to the screen every 1/20th of a second. So that's basically the idea here. Let's see how far we get with this. So what I'm going to do right now, I'm just gonna fry this main.fat here, and we have this little arrow which I was supposed to be able to control, but for some reason I'm not being able to control. Okay, that can happen. Now we're gonna try to debug and see what's going on. I'm not really sure what's going on, so let's see. So one thing we can do is we can use one of the nice features of FatScript, which is a break. Okay, so it has a thing which is called break. Like you have to use like the $sign and then just write break. And what this does is when the code execution executes this line, it will just stop the interpreter and the normal flow of the code, and it will start a REPL session right here with the whole scope that we have and everything, and we can see what's going on. So I hope actually that when I press down in this case, it would execute the move down and we would see it. Maybe it's not even reaching there, so maybe that would be why. Maybe there's something else going on. Let's see what's actually going on. So I press down, nothing happens. Okay, so we're not reaching there. The other thing that could be happening is that it reaches this part here, and for some reason, or it doesn't reach this part. Could be as well. So let's put another break here. And we could also have a problem with it not being able to raise, it not reaching here. So I'm just putting some break everywhere. Maybe I know why we didn't see it. But before we do this, the reason why could be because to enable break, you need to put it in interactive mode. So I hadn't done that before. Now I have added the interactive mode, so that should now work. But it doesn't work because for some reason it doesn't really work. So I'm just gonna enable these breaks as well. And I hope actually that when I press down, it will break at least here, which would be inside the loop. So I press down and I get it. Inspecting main fat 61 is here. So we are basically running here. And okay, so we know we are at this line. We have a player, right? Player is defined. And there we have our player. I don't know exactly why this doesn't work. So I would expect, let it just continue. So to continue, just press Ctrl D to resume. So it will continue the normal execution. And yeah, it's not, it seems like it's not doing the rest of it, like this erase, move down, draw. This doesn't seem to be working. I think I know why. The thing is, these are not properties of player. They are properties of um, of the actual spaceship class. So maybe that's why. I will do something different here. I was trying to be very smart here, but maybe this won't work the way I wanted. So I'm just gonna say, okay, do it one by one. Player, move down, player, draw. And this should actually work because when you do this kind of scoped syntax, it attaches the scope of player. So if we look here, what we have inside the spaceship is only color pair, position, and sprite. It doesn't really have these ones. These ones live inside something else, which is the spaceship. Okay, so that's these methods, they are in the spaceship. So that's probably why it couldn't find those. And I now looking at it, it makes all the sense to me. But it was interesting that we could use the actual break command to debug a little bit why it wasn't working. So now let's just fix these two. I'm just going to copy this one over here, move up, and yeah. Okay, so now this should kind of work. Let's try again. And I can move up and I can move down as expected. Now I'm going out of the screen there on the top, and I'm also going out of the screen on the bottom. So one first thing we need to do here is we need to limit the space to which we can move actually. So I'm gonna create here like screen, and I'm just gonna use the default size. I'm just gonna call it max, and then I'm gonna put here X. I could put directly the actual value, which is 80, and Y 24, but I'm gonna do one more thing here. I'm gonna put just 23 and 79 because we are working with something which is 0 indexed. So this actually might help me to basically draw things exactly to the maximum position which exists in the screen. For us to see this, we can even, when we initialize here, so this initialize the player, we might initialize the UI, init UI. For now, the UI will be just a bounding box that tells us what is the area of the game, like where can the player actually, what are the limits of our world in the screen. So I'm just gonna do cursors dot box, and it goes from position 0, 0 until position until max. Okay, so you could, yeah, that's probably fine. But we also need to do one more thing here, which is define a color. So I have this color here, which is defined for the player. We're probably going to improve over this here in the future, but for now I'm just going to make something very simple. I'm going to say, okay, I have a bounding box which is like gray. So yeah, let's say gray border is cursors make pair. It's actually funny because we are using pair, but we are using only the foreground color. I could use the background color too, but for now I'm just going to use the foreground color. So color.bright, this is the foreground one, the background is the second argument. Black, which is kind of gray. So here I need to use this color. So cursors use pair, and then this pair is the one I want to use. And this, I could nicely put this into a method, a function, but for now, this will have to do. And it should already render a bounding box around the area that we have. Okay, so now there is one cool feature that that FatScript provides you, which I'm going to show, which is you can say, I want to frame it to, like, organize this thing, considering the size that I actually want to use. So I can say also curses frame to, and then the same thing here, to this size. I actually need to double check this on the documentation. So there is one thing I can do here. I can just call fry, then help, then curses. And then on the help, I can check what frame2 actually needs. It aligned the view to the screen center. So you need to provide how many columns and how many rows you're going to use. So in this case, I can't pass directly max. I will just pass 24 80 columns and 24 rows. That's the size. Or I could just pass max.x plus 1 and max.y plus 1, because that will be the number of columns and rows. So this, what this will do is it will center our game to a specific position in the screen. Now I'm actually curious about the player itself not being the right position. Oh, I know why, because we draw it here and then we moved it. So I'll just move this over here, because anything that happens after that, you see now, it actually works, but missing parameter pair. Okay, what's the problem with the pair? Gray border wasn't there. Okay, now it's here. Now this will work. Okay, so as we expected, but we still can go out of our bounds. So I need to limit this movement. So what I'm going to do is, when I move up, I need to check if I'm not going, if my Y is already like, I don't know, let's put here, limit Y. So we have basically on the top and at the bottom. Okay, so for now, I'm just going to limit, okay, you can go up to 1, because 1 is where is our line, so it cannot actually go to 0 is where we have that border, so it cannot overwrite that or it will create us a problem. And also for the bottom one, it can only go to 22, because on 23 we have that line going on as well. So what happens here is when you move up, we have to put a condition, which is if self dot y is bigger than limit y. Actually, I could do without this self here. If I put it here, self, I don't need this. So if y is more than limit y top, so it executes this thing. Otherwise, it doesn't do anything. And for the same reason, I should also limit the down movement, so bottom. Right. So in this case, if y is less than the bottom where it can go, it will move down. Otherwise, it will stop moving. So if we execute the code again, basically, oops, missing an operand of less. Limit bottom, limit y. Unknown greater than block. Oh, really? It's kind of execute. Let's put here a parenthesis. I'm not sure. This shouldn't actually work like that. But okay, let's try the condition like this. Okay, now that works. Always good to put some parentheses in the code. No, missing an operator of more. I would assume that the problem is with this thing here. So I'm going to move this out. I'm going to just use self here. I don't know. It's not liking this scoped block the way it is done, and it's not happy to work inside it. This condition. It's something for me to examine later. I would actually expect the syntax to work as I have written it, but this is also perfectly fine for me. So I'm going to use this for now because I hope that this will actually work. Value missing of less. Oh, so the problem was not with the syntax. Okay, nothing to do with anything of that. I'll show what I was missing. Okay, so it can't find this y because this is a pause.y. There is no y property inside the spaceship. There's just a position. So I need to test position. Now it will work. Now that won't be unknown. Okay, so now it limits my movement. I cannot go down further. Though it does block my movement here when I get to the top. So I want to prevent that. And there is a specific function for clearing out, like flushing the keys that are stored before you do the next read key. For that, like, again, let's check the help for curses. And basically it's just calling flush keys. Okay, so that's what we are going to do. So when if we can't move up, I think that's actually, it doesn't even matter. If we move up or even if we don't move up, regardless what happens, I think we should just, erase the keys which are stored. What this may imply is that you, if you, it can only do one movement per frame. So it will limit kind of the speed in which the, like, it will drop any commands that are like, if your keyboard is sending more inputs than it can process, it will just drop them regardless of whatever happens. So flush keys, I think actually we could just flush the keys always. Like, we read the key, we wait the time, we refresh, and after we wait the time, just say curses. Here actually, curses dot flush keys. So if we hadn't one, now we will wait for this time to see if any more keys come. So every time when it's iterating, it's gonna drop any keys we don't want. So that should prevent it from locking. Yes, now it doesn't lock anymore, and it still moves very fast. So I think this is fine. This is important so that we don't get, like, when you go down or if you press a key, you don't jam your control. So you can always, like, quickly change the direction. So this is very important. Flush keys. Okay, now I think we already have the movement done right. One more thing we will need is now like particles, right? Like if we want to shoot a particle. So I'm just gonna kind of copy paste this here. SpaceShip is now going to be a particle. We just going to call it particle. So it has also a position, it has a sprite, it has a color pair. Now, one thing that I need to do with a particle is I'm going to add a movement to it. So it does have a movement. I could actually have done here some inheritance to show off how the inheritance works. But I'm going to keep it simple for now. And later, if you would like me to show how this could be done with inheritance, please put on the comments. And I might come back to this same example and improve on it. The main idea here is that the next session will be a continuation of this. I don't think we are going to get the full game today. So I'm just going to make some of it, and we're going to come back to it in the next week to complete more details on the game. So if you have any cool idea you would like to add to the game, just put some comments as well, and I can work those out on the next session. But okay, for now, just the movement. I'm just gonna call it vector. A vector is just basically also an XY direction, so I'm just gonna say, for simplicity, vector is a pos, so it's a position, so it also has an XY, but we know it has a different name, so it has a vector here. Movement has a vector, and you have draw, you have raise, you don't have move up and down, but you need something here, which is update. Okay, so every time you need to apply this movement to the position automatically. So you just call update, and it will take the movement and apply it to the. It will apply it to the particle. Okay, so what we need here is basically the movement and the position. We don't need a sprite nor the color. Okay, so what we do with this two information, we're gonna say something like this. Okay, so something like that. So we're gonna always update the position. There's no condition. So with what? We're gonna say the position X plus movement dot X, and Y is position Y plus movement dot Y. Yeah, that's basically the idea here. And we are updating this position into self, so it's updating itself with the new position. Does this all make sense? I hope so. Because we are doing it on self, I think we don't even need this, and we can just move it all up and remove this bracket. That's actually the code get much less code now this way. Okay, so when I press space, I want to create a particle ahead of my player. So let's just create we need particles, right? We need particles. Okay, so let's init particles. So for particles, I'm just gonna create an array, a list, a mutable list. I need to be updating this, adding things, removing things. And then I need some update logic for the particles. So for the particles, what I'm going to do is I'm going to walk through these particles. I'm going to just use an X, which is the standard operator for FatScript, and I'm just gonna get particle. So one thing I need to check is if I need to remove the particle. So I can just say particles equals particles, and then I return the particle if it should be returned, or I don't return it if it's already out of scope. So for now, I'm just gonna do something very simple. So if particle dot position dot x is bigger than my max dot x, so it means 79. Yeah, so if it's equal, actually, it's already too big. So if my particle is already at its end of life, I am just going to remove it. And that's it. It's just the end of life for it. So that makes it like it needs to be less, right? So if it's less, then I do something with it. Otherwise, I don't return it. So at the end, I need to return this particle because I'm keeping the particles in the particle, like a filter, okay? And then I need to do other things here, which is with this particle, I need to erase it. I need this particle to update, and I need this particle to be drawn. Okay, so it removes the particle wherever it was, it moves it forward, for example, and it draws it again. And then it returns the particle. And if it's not viewable anymore, I don't return it. Even to be more precise, actually, this question could be asked at the very end after I update it, or before I draw it. Like I erased it, I update it, and then is the position still visible? Then I do something, which is drawing it and returning it, so I keep updating it. Otherwise, I just erase it. Does this make sense? Okay, I'm gonna add some comments here. If particle got out of the viewport, just erase it. Okay, I think this is clear now what is going on. But we still need to shoot it, right? So what happens here when you press space? Basically, you say particles plus equals a new particle. And the properties for that, I'm just going to create a color here. So particle color equals curses make pair. Let's do it yellow. And then if particle got out of viewport, just erase it. Okay, particle here. So what are the properties for a particle? So particle needs a position. So the position is going to be, we need it to be ahead of our player. So it's going to be a position. I'm just going to open this to make it easier to visualize what I'm doing here. And I'm going to also open it here, and I'm going to copy the properties that I need to pass down to a particle for it to exist. So the particle needs a position, a sprite, a color, pair, and a movement. So where is the particle? Here. Okay, so the position is the player's position, but not quite. it's ahead of the player, so it's a new position with player position dot x plus 1 and player position dot y. So that's the position where it's going to start. The sprite is going to be, I'm just going to use a dot here. The color pair is going to be, I called it particle color, or it could just be bullet color. Bullet pair. It doesn't really matter. I think bullet color is better. Naming is always a big challenge in programming. So yeah, bullet color. And then movement, I'm gonna say vector. I just want to move it actually in the x-axis in this case, and it's a positive movement, so I'm just gonna put here. Maybe this is gonna be too much. I think one, we have to consider it's gonna be updated per second. So let's put maybe 0.1 to start with, and then we see if this is not enough, we can increase it. I mean per second, no, it's on the frames per second, right? Actually, one thing I should do is I should, so that this actually works, like I can change the frame rate, is I need to divide the movement by frames per second. So we have to think of it, how many pixels do we want to move per second? I think 1 is too little, so I'm gonna just say, okay, 3, and it's gonna do its thing to actually move it smoothly through the screen. 3 maybe too little. 5, let's put 5. I think 5 should be fine. Okay, so if I press space, there we go, we have our little shoot. But one thing I'm not entirely happy is it's not fast enough, and the other thing is when I shoot, it comes like at the bottom of it. So I think it will be nicer if I use a dash instead of a dot, because it will just look more centralized. And here I'm just gonna put like 10. Let's see what this now happens. Okay, this looks much more like shooting. I still think we can go even higher here. Let's use 20. So yeah, that looks, even still it's slow a little bit. Let's go with 30. So it moves just 30. That's almost 1 sec. It's, if we have 80, it takes like almost 2 seconds to get out of sight. I think it's still a lot. It could just take 2 seconds exactly. Like, okay, now it goes kind of, it takes some time, and we can already like shoot and move around. That's basically what our player can do. But you see, we already start to get an idea of what a game like that can look like. Now we need to randomly create the enemies for our game, right? We need other spaceships to be created. So I'm gonna create something similar to the particles. For now, particles basically are bullets, right? Or rockets, or whatever you want to call it. But we could have other things here. We could make the enemies be particles, but I don't think they are particles. So I'm going to create another list for that. Init enemies. Okay, so enemies are going to work in a little bit of a different way. We're going to use some random factor to generate them at some point. I'm just going to create a very simple logic which just like rolls a dice every second and says, do you have a new enemy or not? Or maybe every frame, and like with a chance that you should get a new enemy every, like, I don't know, 2-3 seconds, almost like as fast as you can shoot them, something like that. We can adjust it. We could make it get harder and harder, like when the game goes on, we could have high scores, all of that, just the score and then high scores, all of that we should probably implement. I'm gonna, for now, try to make it as simple as possible. So I'm just gonna create here like another array, another list, which is enemies, which is equal also an empty list. We don't have any enemies at the start, so this thing here is, I'm just gonna remove a little bit of the spaces that are exceeding here. I'm just gonna put a title here, so apply movement to bullets particles. Now we need apply movement to enemies. And here apply controls to player. Update the screen. Flush controls. So actually this kind of belongs to this part here, right? Apply controls to player. So at the end we flush, and here we just say update the screen. Okay, so basically here at the apply movement to enemies, what we need is enemies need to do similar thing, which is enemies are going to be updated by a update function. So we just iterate over all the enemies that we have at this point, and enemies are also going to be spaceships. I'm even wondering if we couldn't have made it all like just a big object that has all of this stuff together. Now I'm starting to see no point in not having it like a single thing. So I'm just gonna add the movement to the spaceship. I'm just gonna call it object. And I'm going to move the update function here. And now we don't need particle. And everything is just an object, which has, for now, all our, it's a game object. The player is a game object, the enemy is a game object, all they have position, they may have movement, they can be updated in many ways. I'm just making them the same thing to make it simple. Now the enemies, when they move here, so you have an enemy, they are also gonna be like bullets but slower, so they also gonna work the same way, like erase the enemy, update the enemy. If the enemy position, they are going in the opposite direction, so if it's bigger than 1, then we draw it again, which is an enemy, not a particle, and we keep it. If enemy got out of the viewport, just erase it. Yes. Now there is one thing, if the bullet if the particle hits the enemy, we need to destroy the enemy, right? So there is one major thing here. Um, Particles don't actually have an ID or something like that, but they have a position, so we could try to destroy the particle by position. Maybe we could think about having some sort of um, ID. We can also try to remove the object by its reference. Like say if something is equal that other thing, then just remove. I think that will also work in FatScript. I'll start with that. It's probably not the most performant thing. We could do the ID if these objects start growing very complex, but for now we can just do that. So here, the first thing we need to see is we have a collision between the particles, like the enemy and the particles. So what I'm going to do is I'm going to do the most inefficient thing that I could do, that could possibly do, which is if the enemy dot pos dot x equals no, not like that. If particles so this the question is, do we have a particle so contains the particle where particle dot pos equals enemy dot pos. I think that's the comparison that we want to do. So if that happens, we need to filter out that particle. So basically what we do is particles particles dot filter where this thing not equals this particle, and we don't return anything for this case because we are destroying the enemy. Otherwise we do all the rest of the code. Let's see if this works. Maybe this was a little bit intense here, what's actually going on. So we check if we have a particle that matches the enemy position. If it exists, we try to filter out that particle and remove it from the list. I need to say particles equals particles which are not that particle. And then we don't do anything else with this enemy. Oh, maybe we should erase it first. First of all, we erase the enemy. Then we decide to update it if it wasn't erased. And then if the new position for that enemy is greater than it's still not out of bounds, and we just draw it again and return that enemy, otherwise he's out of scope. Okay, so that seems like reasonable. Now we need to be able to create enemies. So for a simple fact, that's not what's going to happen, but I'm just going to be able to shoot enemies pressing E. So I'm just going to say enemy. We're going to address this in a minute, but for now I'm just going to do this. It's a new game object. Its sprite is just like this, so it's coming towards us. The vector, it's much slower than a bullet for sure, so let's just put like 10. Maybe you can even put less. I'm just gonna put it like that. It doesn't have the color of a bullet, it does have the color of an enemy. So let's say enemy color is red. Okay, so call it there, enemy and vector -10. So, and the position of it, for now I'm just gonna create it at the exact same place, the exact same height of the player, but at the other side of the screen. So I'm just gonna put it here at max dot x minus 1, because the last one is actually the end of the screen. So I'm just gonna place it at the very end of the screen. I think that's actually fair. Let's see what happens. I don't know. Maybe it will work. Game object, no argument for movement at main. Okay, so we can say maybe that if there is no movement defined, it's just like a vector of 0, 0. I guess this will do. Let's see. I can't shoot my particles again. Something happened there. Oh, apply movement to enemies. Enemies. Okay, that might have been a problem. Okay, I can shoot, and if I press E, we have immutable value or unsupported index operand. Enemies. What was that? Main fat. 142. Enemies. Okay, yeah, that makes sense. So if I press E, it shoots an enemy, and if I shoot the enemy down, it dies. Now there is one problem, you see. It might not hit it. What is happening here is that it just passes through the enemy. Now I'm dead. We don't have a game over. Oh my god. Well, one thing I need to do here is when it shoots at the enemy, I need something better than this. Actually, not this. If particles contain particle where the position, I need to check a range here. Like, let's collide it. Let's create a function. Collide with particle. So we get an enemy, which is a game object, and a particle, which is also a game object. It's a function, it's a method. And then what happens here is not just this. This will return a boolean. So if this happens, then I mean we want the one thing we want for sure is the particle dot position y, enemy position y, they need to match. That's one thing for sure. So if that doesn't happen, let's put it like this. If that doesn't happen, then this is false. So obviously, if we continue to the next condition, this is true. So they are on the same line. So if particle dot position dot y is enemy, not y, x, position dot x minus 1, then this is also true, then this is true. And if it's identical, it's true, and if it's just past it, it's also true. So basically what I'm doing is I'm calling for a range here. We need to actually check if this is good enough. But maybe it will just fix it, and then instead of doing what we are doing here, we will just do collide with particle enemy particle. Oh, we just can do this, right? Oh, we will need the particle. Don't we? I'm not sure. What's the particle in this thing? Oh, if it contains particles, particle filter, not that particle. Which particle? I'm a bit lost here. If it contains, this returns a boolean. I should use find here. So particle is this thing here, which might be found to collide with an enemy, and then I try to remove it from the particles. I think this now makes more sense to me as I'm reading. If I create an enemy, I can still shoot it through it. Okay, that one didn't shoot through. But the particles are just, you know, they just keep moving. They don't end up at the enemy. The collide with is somewhat working. I'm gonna add more conditions. So -1, -2, +1, +2. Now we have a big range there. Enemy, shoot at the enemy. Okay, enemy, shoot at the enemy. I think for the speed at which it's running, it's pretty much safe to say that it won't happen, that it just gets passed through it. Okay, now the only problem that we have is that we shoot it and it just goes through the place all around. We probably could do this in a more efficient way, couldn't we? So if position of the particle is less or equal this case here, and particle position is greater than position. Yeah, I think that's actually better. I'm not entirely sure on the team that this is actually better, but let's just see for ourselves. If I shoot it, it still works. So I guess that must be right. One more thing. We did this, and now we need to remove the particle. So for some reason this part here is not really working. So we create a particle, and then we say particles. We could try to do one thing, minus equal particle. And then put it as a list. Lists can be subtracted in FatScript. So how this works is, let me show you. You have like a list. A is 1, 2, and 3, and then you say A minus the 2 thing, and it will just give you the list with 1 and 3. So that's basically what I'm trying to do here. It might actually work to write it just this way: particles minus particle, and it removes that particle. And it doesn't store the enemy, and it just moves on. Let's see what happens. This is like a side effect which I'm applying to at that point. Now I do have a problem with that. You see, like it did draw it, it just stayed there. I'm not sure if this is what I wanted. So one thing I can do is I just can say, okay, particle arrays. So this is a little bit of a thing going on here. Apply movement to enemies and collide with and collide particles. So there is some logic here to the particle, which is what's going on there. Okay, now both die, and I can shoot and I can move on and shoot another enemy, which comes there. Okay, that didn't work. Right. So this is starting to look like a game. It's definitely far from being a complete game, but I think you already get the idea where this can get. So I think we already took a long time to get to this point, so I'm going to end our session for today. But we are going to continue this game and put a lot more things on it. I think it's going to be a super cool game. We can make it like really sort of open source game. I can put the code later on also on a repository so that you can follow up and make suggestions and all of that stuff. Well, I hope this transmission, this session for today was interesting. And if you liked it, please press the like button so that more people can actually, this video can reach more people. And that's it for today. See you on the next stream.